people.
Good morning.
Good morning. Guten Morgen. Guten Tag. Okay, Danke Schenk. Okay. All right. Ni hao. Yeah, buenos dias. I know. Forget that one.
Konnichiwa.
Konnichiwa.
Why?
Hey, hey, gumbo. Hola. Ciao. All right. Anyway. All right. Okay. Find f prime if f of x equals x cubed minus 1. We did this one yesterday, and we were talking about this in depth about the graphs. So we talked about this yesterday on because this is an x cubed. And when I actually go through and do my derivatives, I actually lose a power every time. I lose one of the degrees every single time I do this. So if I'm starting off, my function is at x to the third, my derivative is going to be x squared. And that's what we ended up getting. Okay, so, and we were talking about the slopes every single time. So on this first one right here of f of x, everywhere here, all my slopes, it's either positive or 0, right? Okay, it's going up. There is no place on this graph where my graph is actually going down, is there? No. So my graph of my derivative is this green one right here. That's what it is saying. Everything is in the positive, right? Everything is a positive number. So my derivative at -1 is 3. So the slope at -1 is 3. The slope at -2 is 12. Okay? So that's what we're going to do here. So that means that the slope here, this is positive. So at -2, where I was down over here, at -2, the slope is 12. That means that it is rise over run. So it is 12 over 1, right? It goes up 12 over 1. So if I were to extend this whole thing out and actually get a straight line, my rise over 1 would be 12, up 12 to the right 1. Okay? Same thing over here on the right-hand side over here. So on the right-hand side, so at 2, so when x is 2, my slope is also a positive 12. So I go back over here to my function, my slope is a positive 12. Does that help out a little bit? Questions? Okay, all right. So right here, graph of the derivative function, use the graph of the function y, okay, shown right here. And so let's take a look at this. Now, if I was to graph the derivative of this, I know at a couple things. Okay, at this point right here, what's the slope of the graph at -2? Nope. This is the function. This is the function right here.
0.
Okay, the slope is 0. Very good. So I know that the slope right here is going to be 0, right? So my derivative, as I'm graphing it, I'm going to have a couple key things here. All right, so now at -3/2, or on positive 3/2. It's again at 0, right? So my slope, my derivative, if I'm graphing a derivative, right here, I know that this is going to be a 0 right here. Okay? Now, let's take a look at everything on the right of 3/2. From the right of 3/2, it's all going to be what? Positive. It's all going to be positive, right? It's all going to be positive. So I know that all this up here has to be positive. So it's going to be positive like this. Okay? Now, let's take a look at -2. -2. So to the left side of -2, what is happening if I'm looking right here? The slopes of this one right here is always going to be what? Positive. It's going up, isn't it? So the graph of the derivative should be above the line, right? So it should be in the positives. So it should be, again, positives here, right? So it should be positives there. Now, from -2 to 3/2. From -2 to 3/2, what is that slope doing? It's going down. So that if it's going down, whenever it's going down, it has what? A negative slope, right? If it's going down, the slope has to be negative. So that means when I'm doing this, it's all going to be right in here. Something like that. Okay? So I could do the math on this one right here, but I want you guys to actually look at each one of these and identify your key points. Like I did when I started this. I started at, okay, where's my slope 0? There's my points where it's crossing the x-axis. Okay, what is it happening on both sides of that 0? Okay, if it's going up, that means that it has to be in the positive. If it's going down, it has to be in the negative. So, let's take a look at my function, the blue one right here. The function. What degree is that function? Third degree, right? Third degree. Third degree. So if I look, okay, that's a third degree. Remember when we did the hands the other day? Okay, remember your hands, right? Going up, x squared should be like that, right? Okay, x cubed, one up, one down. X to the fourth, either both up or both down, right? Okay, so now, that's why this is a third degree, right? One up, one down. So I'm ending up and I'm starting down, right? So if I reduce that, if I take away one of my degrees, so my third degree is now going to turn into a second degree. And a second degree is a parabola. This is my parabola in red. Does that make sense there? Okay, so that's what we're doing every single time. So we found those key places and then we sketched a graph for it. I don't have an exact for this, but you know, that's what it is. Work. Okay, there we go. Given piecewise defined function right here, determine if f prime of 1 exists. Now, the definition of this says that to take a derivative, I need a couple things to happen. It has to be what? Continuous. Has to be continuous, right? Has to be continuous. And then the slopes, okay, either side, it shouldn't be a pointy point. So it's not going to change signs at that right there. So let's take a look. So if this is going to be continuous, plug in 1 here. So that's going to give me -2, right? -2 plus 4? 2. So I get 2. So this is 2. Okay, for this to be continuous, this other side of the piecewise has to be 2, right? So let's see. So it's going to be 1 squared plus 1 is? 2. All right, so I have continuous here. Okay, so now we have to look at the derivative. So now, for this, I have to see what it's going to be on this side of it. Okay, on the less than side of it. Okay, so on the left-hand side of it, we will look at it and go, all right, so I'm going to do a change. So let's go with my -2x plus c squared plus 4 minus, where are we finding it at? We're finding it at 1. Okay, so it's going to be -2 over, what do we put down here? What is it? C. So when we're plugging in the point right here, what do we have here? Remember, if we're graphing points, we're doing slopes in between 2 points, right? So my first point would be x comma f of x. And my second one should be my c comma f of c. Right? Okay, so my c here is what? What was my c here? 1. So the c is 1, right? So c is 1 here. Okay, so this is the other kind right here. When we have a point, it's the other kind. I'm not finding it with that one. It's the other kind where we have my points. So now this one right here, okay, define this one right here. This is going to be my 1, right? 1 comma 2. That's going to be this point up here. So as we're doing it, we have to find the slope at that point right there. So we could do either method. So we could do it as, because you guys are actually confusing both sides of this. So since we have 3 different methods for this, we could actually find the slope first and then plug in that number. We could do that as the limit goes to c. Or we can go through and just do the slope formula for this. You want to do slope formula for this? Okay, so kind of like what we did on the warm-up. You guys remember on the warm-up? Let's do this one first. Okay, so you guys can see what we have here. Okay, so it's the x plus c, right? X plus c minus f of x over c. Let's do that one then. So it's going to be the limit as c goes to 0. I have f of c, so it's negative 2x plus c squared plus 4 minus, what's the next one? F of x, right? So my f of x is going to be negative 2x squared plus 4 all over my c. Okay, we're following just what we did on the warm-up today. Okay, so now from here, do my distribution. Negative 2 parentheses x squared plus 2xc plus c squared plus 4 minus, becomes a plus 2x squared minus 4. All this over here is going to be over my c. So distribute negative 2x squared minus 4xc minus 2c squared plus 4 plus 2x squared minus 4. And so what's going to happen here? I'm canceling out this one right here, right? I'm canceling out this one right here. I'm canceling out the positive 4, canceling out the negative 4. So I'm going to be left with my negative 2c squared minus 4xc all over c. We're taking the limit as x approaches c. Or I'm sorry, not x approaches c, c approaches 0. Sorry. C approaches 0. I have it written up here and I still screwed it up. All right, factor out the c. So c, then I'm left with negative 2c minus 4x over c. I can cancel out that c, and now I can take the limit, right? So if I take the limit as that approaches 0, I get negative 4x. And we said that this is, my negative 4x is the f prime, all right? So it's going to be the f prime of x, negative 4x. So I have the derivative of the top, okay? I have the derivative of the top. Okay, so it's a negative 4x. So if this should be right, it should be similar slope right there on the other side. So let's take a look. So I'm going to erase this part right here, and I'm going to do it again, but I'm going to do it for the other one, the bottom of the piecewise. So if I'm doing it for the bottom of the piecewise, so this one's going to be x plus c, right? Squared plus 1 minus x plus 1, x squared plus 1 over c. So x squared plus 2xc plus c squared plus 1 minus x squared minus 1. So this, and this all go away. So I'm left with 2xc plus c squared over c. We're taking the limit as c goes to 0. Factor out that c. I'm left with 2x plus c over c. So this is going to give me 2x. So the f prime of the other side is going to be equal to 2x. So I have a slight issue on this. Okay? I have a slight issue on this. Now, this is where it comes into play, where it is continuous, but this is going to be a pointy point. Now, if I'm looking at the tip of a needle, can I find the slope at the tip of a needle? It's not going to be 0. This is the tip of the needle, because on the left-hand side of this is negative, isn't it? So the left-hand side, it's going to be a negative slope, isn't it? But the right-hand side is going to be a positive. So that means that that is going to a pointy point there. So since it's going to a pointy point there, I cannot find the slope, because I could put something on that pointy point and try and balance it, but I'm not going to get a slope at that point. Okay, I cannot get a slope at that point there. Does that make sense? So, no?
Well, I understand the math. I just...
No, the balancing part. Okay? So if I have a gentle curve right here, I could, come on now. Come on. Hey. All right, so I'm trying here. Okay, so right here. So for those people in Donkashin, you guys are, I'm actually balancing a ruler right here. So because I'm doing this like this, I'm able to, like, easily, you know, I can find the slope. If you notice, here's the slope of my curve. So on this side, okay, it's going up, going up, going up, going up, going to 0. So going to 0 flattens out to 0 right there. And then the other side starts going down, right? Okay, the problem is, I don't even think I can do it. This is, yeah, I'm trying to use like fingernail to try and get this.
Do you need help? No, I'm serious.
That's the point. That's the point. Okay, so if it's very pointy right there, it's not that gradual curve up to it, okay, because it's changing slopes from one side to the other. So it's going to be a negative and a positive change right here. So with the negative and the positive change right there, that means that it's going to a pointy point. I cannot take a derivative at that pointy point. Okay? So when I do this, I have different sides of this. So this, you cannot take a derivative at that point. So it's also goes to say, now, you guys know what an absolute value function looks like. It's just a consummate v, right? It's just a straight v. I cannot take a derivative at the point of an absolute value. I can take it on either side, but I can't take it at that point. Make sense? Okay? This is one of the rules that when I take a derivative, okay, it can't be at a pointy point. All right, so now, okay, now here's what it looks like. So I have the top one in blue. Okay, so right here. So if you notice, let me trace it blue again. So I'm tracing it here. And right here has a corner. Okay, it's a corner. It is a pointy point. So the left-hand side of this has a slope of -1. The right-hand side of this has a slope of +2. So because this is coming down right here, it is that pointiness that I can't, oh, dang it, wrong one. All right, this one right here. All right, So we get that point right there. So has a corner. So it's turning the corner. It is a pointy point. So if we're actually referring to this, and it says what type of discontinuity or what type of reason I can't take a derivative there, I would say that this is a corner of this right here. So at a corner, it turns a corner. We can't get a derivative there. That's one of the rules. You cannot take a derivative at that pointy point at the corner. Okay? All right, showing that function has no derivative. Has no derivative at 2. Now, this one I'm going to go through and I'm going to show you with a calculator. So, please make sure your calculator is in the right mode. I think I updated everyone's already. Let me make sure. Real, yeah, okay. Last time I did this, it wasn't on real. And so when I was doing my video for Calc 2, I was like, why does this keep coming up? All right, so x minus 2 to the 4/5. All right, so graph.
How do you change it?
I already sent it. Is that the degree?
It says rad.
It's supposed to be rad. Yeah, calculus always works in rad. All right, parentheses. What is it, x minus 2? Is that what I said? Yes?
Yes.
Close parentheses, raised to the 4/5. Okay, enter. Now, if we're looking at this, we're looking at the slope of the line on the left-hand side. Because remember, derivative always has to do with the slope. Derivative always has to do with the slope. Okay? The left-hand side over here, and then the right-hand side at 2 over there, right? So, of this one right here, I can come to the left-hand side of this, find the slope, to the right-hand side of this, find the slope. But if you notice at that point right there, that is a corner. I cannot take a derivative at that point. Okay? I can go through and do the math for this to use the algebra way, but, you know, this is so much easier with the voodoo method. So I don't want to, you know, bore you with the algebra on this. I'm just showing you why it doesn't come up. Okay, because I think I'm already starting to bore you guys. Okay, see people start breaking on their phones and start, you know, putting headphones back in. Yes, I see you there.
I am come back in.
Okay, all right. So there's that corner. Okay, obtaining information about y equals f of x from its graph of its derivative function. Now, A. So for this right here, does the graph have any horizontal tangents? If yes, explain why and identify where it occurs. Now, horizontal. What does horizontal mean? The horizon, right? If you look at the horizon, the word horizontal comes from horizon. So it is like that. So is there any place in here that is like that? Nope. Okay. So it's not. So I'm not going to have any. So now, no horizontal tangents, right? Okay, good. So that means it's not going to have any mins or maxes on that. Does the graph of f have any vertical tangent lines? Yes, there is going to be a vertical tangent line here. Now, this looks like it's going to be, it's close. This is going to be an asymptote here. Okay? It's going up. It's eventually going to come up to a 0 because as an asymptote, remember, it goes on forever with it never touching it, right? So this eventually goes up to 0 on both sides of this right here, right? So this goes up to a positive infinity, and the left side of this also goes up to a positive infinity here. They both go up to positive infinity because I have a vertical tangent line here. So, a vertical asymptote. So it eventually gets to the point where that slope will be so close to 0 that I could say, hey, you know what, this is going to be basically 0 if I get close enough up to that. Okay? Now, let's take a look at the next one right here. Now, for this one right here, why would this right here be a asymptote? Why would it be an asymptote? What happens when you get asymptotes?
Never
No. Mathematically. Why do I get an asymptote? We did this on the limits.
Something divided, like it's divided into.
Excellent. Very good. Divided by 0. It's divided by 0. Okay, so if it's divided by 0, now think of your slope. What is rise? Oh, dang it. Okay. Slope is rise over run, right? Yes. Okay, slope is rise over run. But once we get to this point right here, if I have a slope of, okay, so if I do a rise of 10 and a run of 0, okay, that is undefined, isn't it? That is undefined, so that's where I'm going to get that right there. So I'm going to get an asymptote whenever I have those. Okay, it works a lot more when we get later into this and we get 0 in the denominator, or we're taking the slope of a circle or something like that. So you're going to have a circle and it should have 2 places where the slope is 0 and 2 places where it has a undefined slope. Undefined slope is 0 in the denominator. Okay, alright, so tangent line where a point is a cusp of f. Okay, does the graph have any corners? Is there any corners here? No, there's no corners. Okay, what is this thing right here? This is a jump. The jump discontinuity, right? Okay. Alright. Differentiability and continuity. If a function f has a derivative number c, then it's continuous at c. If a function is discontinuous at number c, then you can't take a derivative. Okay? So, differentiability implies continuity, but continuity does not imply differentiability. Here's another example. All thumbs are fingers, but not all fingers are thumbs. True. Okay, so if I back up a couple slides, actually no, I don't want that one. Oh yeah, I do want this one. Okay, was this continuous? Yes, it was continuous, but we can't take a derivative there, right?
Yeah.
So, continuity doesn't mean that you could take a derivative. But if you could take a derivative, that means that it has to be continuous, right? Okay, that's what I was trying to get at. So, fingers and thumbs, thumbs and fingers. Okay, alright, so this one right here, differentiability, countability, f is continuous at 1 and f of 1 exists. So I can take a derivative here. G is continuous at 0, but g prime of 0 does not exist. Okay? Huh?
Because it's orange.
Yes, that is a corner. Alright, h is discontinuous at 0, so h prime is also discontinuous at 0. Okay? Alright, there we go. I think that one's it. Alright, don't forget, like and subscribe.